Hello, welcome back. Today let's try to solve another Leetcode problem. 1143, longest common subsequence. So this is a very famous problem. So we are given two texts. Text 1, it is A, B, C, D, E, and text 2 is A, C, E. So the longest is A, C, E, because inside the text 1, for the sequence, there is A, C, E, and a common subsequence. Yeah, we just need to find one of them. And in text 1, we can find this ACE. And ACE is a subsequence of A, B, C, D, E. So that is why the longest is 3. Now, let me go to the whiteboard to explain my solution. After that, I go to the code editor to finish the coding. Now, let's try to see the example. Yeah, before that, we have text 1, A, B, C, D, E. Now I change a little bit. I change the text 1 to ACE and the text 2 to A, B, C, D, E. So for solving such problem, normally we're going to use DP. We're going to use DP to check dynamic programming to check what is the longest subsequence. Yeah, before that, we need to think about some examples. So yeah, let me give you two examples. So the first example is what if the string, the character equals to each other. So for example, yeah, let's prepare a string text 1. Let's prepare maybe A, C, yeah, still ACE, and text 2. Let's prepare maybe ACB. Yeah. Let's check two situations. The first step is what if the characters equal to each other? What if we just have AC and this here we also have AC? What if this C equals to this C? We will not consider this B yet, and we will not consider this E yet. Yeah, what if we have AC and AC? What if this character C equals to this C? So it means we're gonna check all the characters before it, and this one also the same, all the characters before it. It means if the characters equal, so for the DP, IZ, so DP IZ should equal to DP I minus 1, J minus 1, plus 1, plus 1. So this means if they are equal, we just need to check all the characters before them, and this all the characters before them. So this is dpi minus 1 and j minus 1. So dpij means at the index I, for example, I for the first for the text 1 is used the index I at this index I, and at this index, for example, here we use the AC, here we used I, and here AC we used J. Yeah, it means before this I, including I, here before this J, including J, if they are equal or not. So this dpij equals to dpi minus 1, J minus 1. It means this A and this A, it is 1. 1 plus 1, it is 2. So this is for checking if they are equal. So what if they are not equal? So for example, we are going to check this character E in text 1 and character B in text 2. So what if we are going to check shifted to this E and here shifted to this B? Yeah, so if they are not equal, what we are going to check? Yeah, we need to check two conditions. So for one condition is we are going to check if this AC, what is the longest common subsequence of AC with ACB? So this is one situation. Another situation is what if this ACE compared with this AC? Yeah, so it is still 2. So the longest subsequence is 2. Yeah, so this is not a good example. Let's prepare another example. For example, it is, let me prepare ABC maybe here. Yeah, and for this one, let me prepare let me prepare a B, C, A. Yeah, so we have two texts. One is ABC, another is ACB. So what is the longest? maybe you think AC is the longest. So how can we get AC? So we will, if they are not equal, if this is C not equal to this B, so it means we're gonna compare this AC with this ABC. So what is the longest? It is 2. Or we can compare this AB with this ACB. So it is still 2. Yeah. So the longest is the maximum of them. It is still 2. Yeah. So if they are not equal, can we check the characters before them? If they are not equal, this AB, this AC, it is only 1. So it means the result is 1. It means it's not right. We have to compare. Yeah, if they are not equal, so the dpij should equal to dpi minus 1 with j with I dpi and j minus 1. Yeah, so the maximum of them. So this is also a dp. So we are going to check the maximum of those two results. Yeah, now let's just go to the table to check one by one for our formulas. Yeah, so if we have a string, this is a text to A, B, C, D, E. I will put it in columns. So this is index 0, 1, 2. This is index 0. This is 1, 2, 3, 4, and 5. And here is index 0, 1, 2, 3. This is for the rows is for text 1. So this is ACE and this is ABCDE. So we're going to check one by one. But from the empty string, it's always going to be 0 because the longest common subsequence with the empty string, it will always be 0. So after that, we're going to check. If they are equal, so it's going to be 1 plus here before it. Diagonal areas is here. So it is 1. Next, A and B, they are not equal. We take the maximum of this one and this one. So it is 1. And next, it's not equal. So it will be 1. D and E, if they are not equal, it will be the maximum of 1. Now we go to the next. If A not equal to C, we're going to take this number and this number. So the maximum is 1. And 1 B not equal to C, we're going to take this one. So the maximum is still 1. And next, we're going to check C equal to C. So it will be 1 plus 1. So it will be 2. Now we are going to check the next. They are not equal. We will take the maximum of 2 and this 1. So it is a 2. Now we are going to check this number. This one, E not equal to C. So we are going to take the maximum. So it is a 2. Now we are going to check the last row. So this is 1 because A not equal to E. We are going to take this number. Now B not equal to E. We are going to take the maximum of this one and this one. It is still 1. Now we are going to check this C not equal to E. So we are going to take this one and this one. Maximum is 2. Now D and E not equal. So this one and this one is 2. For the last one, E equal to E. So it will be 2 plus 1. It's going to be 3. So this is the result. Now let me go to the code editor to finish the coding. So for such problems, if we solve this problem, normally we can solve many Leetcode problems because they are similar. Because this is a pattern of dynamic programming of longest common subsequence. Yeah, now let's just finish the coding of this one. After that, we're going to use this template to solve many Leetcode problems. And by the way, this method is ON square. And let's check the text. The length is 1000. It means we can pass for the Leetcode. Now let me prepare for row and column should equal to length of text 1. So rows will be text 1. Yeah. And the column will be length of text 2. So this is just for me. You can also prepare the row as text 2. It doesn't matter. Yeah. So this is text 2. And then we're going to prepare the DP. So DP is inside. It will be 0 times row times column. Yeah, because this is a column. And for R in range capital R, so this is for the DP array. After that, we just need to loop through the DP and find the longest. Yeah, so for r in range r, so this is gonna be 1 to r, because for 0 we already prepared as 0. Now let's check the columns in range 1 to columns. We're gonna check two conditions. Yeah, if text 1 r minus 1 not equal to text 2 c minus 1. If they are not equal, it means we're going to check the maximum. So the dprc, yeah, you can also use IC, it's the same. Yeah, so I'm going to use the dprc for easy to understand for row and columns. Yeah, so it will be the maximum of dpr minus 1 with c and dpr with c minus 1. So this is one condition if they are not equal. So if they are equal, so dprc would be equal to dpr minus 1 and c minus 1 plus 1. Yeah, because we're gonna take the same character. For example, this c equal to this c, we're gonna plus a 1, and dp is all the state before those. Yeah, if we take this c, it means left behind is a, and left behind is ab. Yeah, so ab and a, so the length is 1 plus 1 is 2. So that is why here. Yeah, basically this is the entire code. After that, I just need to return dp minus 1 and minus 1. It means at the last position of both text 1 and text 2, I'm going to check what is the longest. Now let me run it to check if it really works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases. Thank you for watching. See you next time.